Hey Evie, I'm good, thanks. Nothing much up. What's up with you? Did you get the email I sent, by the way? I sent you the answer to your question a few days ago. Yeah, perfect. Okay, good. I hope that made a bit more sense. That was a tricky question, to be fair. I know, trapeziums suck, but the thing is, breaking up into like a rectangle and a triangle, it makes it really confusing as well, because then you have the different like lengths and all this other stuff. It's not great, not great. I think we'll wait for maybe a minute or so. But what I was thinking of doing today is, you know, who had that like preparing for grade 9 paper 1? I figured we'd quickly go over the stuff we did for paper 2. Hey, Ice Cream, how are you? And then we'll go over the rest of paper 2, and then next week we can do paper 3, and then you're kind of used to the hardest possible questions that you can get, really. Maybe we'll do some more of these papers too, because there are a few more. But for now, I'm just going to quickly go over the stuff we've already done, and then we'll just, because I think we only did 3 questions or something anyway, and then we'll finish off paper 2. Yeah, I'm pretty good, thanks. Do you need to know strong force? I think you just need to know that it exists for physics. So when they're talking about the 4 fundamental forces, strong, weak, electromagnetic, and gravity. So you just need to know it exists. Okay, so with paper 2, we did a few questions last week, but not too many. The first question was just the equation of a curve was y equals a to the x. State the coordinate of a, so that's just the y-intercept. So you sub in x equals 0, nice and easy. And then all we had to do was sketch basically a circle, which is basically the same as sketching an equation of a curve. So the circle here was normally on top of the origin, and then we just shifted it to the left by 3. Nice and easy. For question 2, we had to work out an estimate for the distance the train travelled, and we already knew how to do that. All you need to do is break it up into rectangles and triangles, or just trapeziums, and work out the area of all of those, add them up. All done. It is a calculator paper, so it wasn't too bad, hopefully. And if it's an under and overestimate, you just look at how the lines look. In our case, it was an overestimate because my line was above the curve. Lastly, for part 3, we have essentially an iteration question. It was pretty easy, just 1 mark. So at time t equals 0, the tank is full of water, and then there's 2% less. So that means it's 98% every single time. So 0.98, easy peasy, lemon squeezy. So for question 4, it gets slightly more tricky. We have a bit of geometry, and it's a 5-mark question, so you can expect it to be a bit of a fat one. And here's the situation. We have OAC, so this thing here is a sector of a circle, radius 10 meters. BA and BC are both tangents to the circle, and this angle here is 120 degrees. We just need to work out the area of this shaded region. What I would do in this case is I'd say, okay, I know I'm going to need to work out the area of this sector, right? That seems fairly obvious. So, how do I work out the area of a sector? Well, if you remember, a sector is just a fraction of a circle, right? So I could continue this and make it one big circle. Now, what fraction is it? Well, all you do is you take the angle that you're given, and you divide it by the total angle in a circle, which is 360, and then you times it by pi r squared. So in this case, it's just a third pi r squared. If it asks me to express my answer in terms of x, does my answer need to be in its simplest form? It doesn't have to be in its simplest form, unless they specifically say simplest form. So why don't we start off by just working out what this value is. So in our case, it's 120 over 360 times pi times 10 squared. And I'm just going to use a calculator because, of course, we can. You have such a good question you'll send me. Alright, yeah, we can do that as well. That'll be fun. Hopefully it's not too difficult and I end up making myself look like a fool. And then pi times 10. That should work fine, obviously. 104.72, I'm going to call it, okay? 104.72. Now that would actually already give me marks, right? So if you're ever unsure, just try working something out. So specifically in this part here, this would be worth 1 mark already. So it's better than getting 0 out of 5, getting 1 out of 5. Now to work out the rest of it, this is where it gets a bit more interesting. Proportion, do you always have to work out? That's a good way that works, yeah. So you don't have to do that, but that is a good way for it to work. So the machine hours where you times the like the labour, so whatever it is, times by the hours, yeah. That's the way I used to do it. There is like a more logical way you can do it, and maybe we can come up with a question a bit later on to do with that. So the question is, how do I work out the shaded area? Well, to work that out, I'd have to do this area of this shape, and then I'd have to find out somehow what the area of this total quadrilateral is. So in fact, it's a kite. So with a kite, if we split it down the middle, it's symmetrical. Now, does it make sense that it's symmetrical? Well, BC and BA, if you remember your circle theorems, tangents from the same point are the same length, which means both of these are the same length. And this is both the radius. And obviously this third side is the same because they share it. So because of SSS, these are all both the same triangle. So I'm going to work out the area of one triangle and double it. Okay? So, what type of triangle is it? Well, it actually is a right-angled triangle, which is the interesting thing. Now, if I just kind of extract this triangle out, I'm going to draw like this. So we have B here, we have C. This angle here is going to be 60 degrees because remember I've cut it in half, right? And this side here is 10 meters. So what I can do is use trigonometry to work out the opposite side and just use half base times height to get my answer. Okay? Such a good question? I think so. To be honest, I wasn't too sure what to do until I got this sector first, and then I could kind of piece it together. So it is what I'd recommend. So this is our hypotenuse, that's our adjacent side, and this is our opposite. Hey Mar, how are you? So just so you're aware, we're continuing the paper 2 we started last week, the aiming for a grade 9. So I just went over the previous questions, just quickly showed everyone what we did, and now we're doing this pretty hefty question. We're working out the area of this shaded area, which is quite interesting. Have a read through of what we've done so far. If you're not too sure, I'll go over it one more time, okay? So if I want to work out this opposite side, because remember with the area of a triangle, it's the base times the height, I would use O and A, so it's TOA. So we have tan 60 equals, is acceleration? Yes, it is EV. Is equal to opposite over 10. So the opposite side is just 10 tan 60 equals the opposite. So what does that equal? I was about to use my phone for some reason. Let's use my calculator. It's in degrees mode, perfect. So 10 tan 60 degrees is 10 root 3. So I'm going to leave it in terms of surds for now, just to make sure my answer is nice and accurate. And that would give you a mark. And realizing that this is 90 degrees also gives you a mark. So I've got 3 of the 5 marks already. Pretty good. So the area of this total shape, so I'm going to call it area of OABC, is equal to 2 times, because remember both of these triangles is the same, they are the same, sorry. So we're just going to work out the area of one and double it. A half base, which is 10, times the height, which is 10 root 3. So as you might notice, the 2 and the half will obviously cancel out. So 10 times 10 root 3 would be 100 root 3. So lastly, the shaded region is just going to be the area of this overall kite shape minus the area of the sector we worked out. So 100 root 3 minus 104.72. So times 10 equals... whoops. Okay, let's do it this way then. 100 root 3 minus 104.72. 68 point... It says to 3 significant figures, so 68.5 meters squared for the And yeah, you get a mark for this, and then a mark for this. So, mark for realising that this is 90 degrees, a mark for using trigonometry to work out the other side, a mark for working out the area of a sector, a mark for then doubling the area of the triangle, and a mark for working that out. So, Mar, is that okay? Because I know you joined maybe partway through that explanation. And Evie, Ice Cream, is that okay? You do get asked to truncate things in exams, Alila. You do. I actually saw it in a foundation paper as well. And that really threw people off, even threw higher students off, because it's very it's unusual. So, all good? Yeah, so, okay, let's quickly talk about truncation. It's really simple. It's actually not that bad. But let's say I have, like, sorry, one sec. 104.78, right? So if I asked you to round it to the nearest whole number, you would say 105, right? Nearest whole number, easy. Or to 3 significant figures, or whatever else you want to call it, right? When you truncate something, to truncate something means to cut off the end, okay? So if they were to truncate this number, don't you just cut the other? Yes. So if you were to truncate this number, all you're doing is cutting this part off, so the answer would be 104 instead. So basically, when you truncate in maths, you get rid of the decimal. You don't round, you just eliminate it. You just rub it out, right? That's all you need to do. Hopefully that makes sense. And this is called truncation. Yes. It's literally so when you truncate something in real life, it means to cut the end off of it. To truncate in maths means to cut off anything that isn't a decimal. You don't round or anything. You literally just do what I did. Cross out the decimal. Which is why I use this number, so you could see the comparison between rounding and truncation. Sometimes rounding and truncation is the same thing, but not always. For degree of accuracy for bounds, you use upper, lower, and original. Yes, yeah. Oops. Okay, next question. Sketching the tan graph. I'm hoping this isn't too bad, but what the tan graph looks like is every 180 degrees, you have an asymptote. The annoying thing is that it starts at 90. So you have your first asymptote here at 90 degrees. And then every 180 degrees after and before it, you have another asymptote. So you have another one here, because 180 plus 90 is 270. You'd also have one at minus 90. So plus or minus 180 degrees, you have asymptotes, where the graph should never touch. And from 0, it just kind of shoots off to infinity. Again, make sure it doesn't ever touch the asymptote. And then if you have it in the middle, it's going to look... This is going to balance through here, and then... Again, a bit shaky. Yeah. Technically, this would continue on, but they only want it until 360. Okay? So you just draw this same shape again and again, but you cut off any bit that you don't need. So in this case, I didn't need beyond 360. Is anyone unsure of that? Perfect. Hopefully the sketching the graph isn't too bad. But you get a mark for your asymptotes and a mark for the shape for this question. Good, good, perfect. Nicely. Nicely? Well done. Okay. This one, in my opinion, it's not difficult. It's just really bloody tedious. Okay? So, there's a few ways I can show you how to do this. One way is to do it all in one go, right? Now, when you subtract fractions, the first thing you need to do is make all of the denominators the same. So if you look at this first fraction, I would have to times it by x minus 3 and x plus 3. So does it make sense if I just write... So I've times the first one... Oh god, my voice cracked. I times the first one by x plus 3, x minus 3. Does that make sense how I got from here to here? That's what you do? Yeah. You can do it even faster than this, by the way. So what you could do is actually do this addition as well at the same time, but either way. The middle one just gets times by x plus 3. So we have x plus 2, x plus 3. Again. What I will say about this is it's very, very easy to make a mistake. And the last one is times by x minus 3. So be extremely careful. The reason why I say that is that these are all subtractions. So you're actually subtracting the whole bracket. So when you expand it, you need to flip the sign of everything, not just the x squared. Where I lost my mark. Exactly. It's easily done. Easily done. So if I write this all as one fraction now, again, I'm taking a slightly slower approach just to make sure we're all on the same page, but also to make sure I don't make a mistake. This is a 4-mark question, so you don't have to be that quick about it. And it's extremely tedious. Okay. Now, oh god, yeah, I forgot about that. I can actually see, can you see this bottom, this denominator will actually already make the x squared minus 9, right? Because it's x minus 3, x plus 3, so I'm actually just going to write x squared minus 9 from now, just to make myself feel better, because I'm closer to the answer. Expand the brackets, we're going to have, I don't know if this will make much, actually no, let's do it in steps. So we have x squared, and then we have minus 3x plus 3x, and then minus 9. Then we have minus x squared plus 5x plus 6. And notice how I'm keeping the brackets just because there's a negative in front. X squared and then minus 6x, so minus 9x plus 18. All over x squared minus 9. And now you can actually start to gather your like terms, right? So I have, if I look at the x squareds, I have 2x squared here, minus x squared, so 1x squared, minus another x squared, so I have 0x squared, and what I'm going to do is I'm just going to put a line through these. If I turn towards the end, I have a question later. Yeah, perfect. So you can send it in the chat or to my email, and we will go through some of your questions afterwards. Yeah, Evie's going to as well. With the x's, we have minus 5x, then minus 9x. So that's minus 5x plus 9x, which would be 4x. So now we can cross out the x's. And then we have 2 times minus 9, so that's minus 18. Minus 6, that's minus 24. Then minus 18, which is minus 42. Yeah? And if I have a look at the answer, it says, oh god, my voice, ax plus b over x squared minus 9. So a is 4, b is minus 42. Is it better to multiply by negative 1? Will that reduce mistakes? Yeah, so expanding out the brackets might have been a better move. So just to make sure you don't make mistakes. So if I expand this whole thing out, I'd get 2x squared minus 18, then minus x squared minus 5x minus 6 minus x squared plus 9x minus 18. And bear in mind, I don't need to put the denominator because I'm just using this to get to the next step and then go through the whole thing. That could be a better mistake. That could be a better thing to do, indeed. Okay. For 4 marks, I don't think it's too bad. It's a bit tedious, but not too shabby. Okay, if there are no questions, then we go to the next one. Okay. I do like these questions personally. So we have this kind of setup, and you wait for my question. I'm not waiting now, no. We'll do it at the end of the lesson, I promise. What you want to do here is... Oh, right, I see. Wait for, yeah, I bet it will be. What you want to do is write all of these numbers in terms of their lowest base. So what I mean by that is, if you look, I can write 2 and 8 as powers of 2, right? So 16 is equal to 2 to the power of 2, 4, 8, 16, 4. And 8 is just 2 cubed. Yeah. So I can just sub this all in to this equation, okay? So I'm replacing 16 with 2 to the power of 4. And that's still to the power of 1 over 5. then it's times 2 to the power of x, and then that equals 2 cubed to the power of 3 over 4. Now what I'm going to do is actually multiply out these things. And if you remember your rules of indices, when you have a power, so let's say 2 to the power of x to the power of y, you times them together. So I'm doing 4 times 1/5, so that's 2 to the power of 4 over 5, times 2 to the power of x equals 2 to the power of 9 over 4. Okay. Now, if you have a look, I have everything to the base 2. Now, when I times these powers, or these bases together, I'm going to add the powers. So for this equation to work, I have 4 over 5 plus x has to be equal to the thing on the left-hand side, 9 over 4. All good with that? So again, because I'm going to add these when I times them, this power plus this power should equal this power. And then from there, it's just subtraction. Now again, since this is a calculator paper, we could technically do a bit of a cheeky one, and instead of bothering with the fractions, just do 9 over 4 minus 4 over 5, so we don't have to worry about actually working it out. 29 over 20. Yeah, easy, exactly. I do like those questions, and if you're going to do A-level maths, these come back pretty heavily, so that might be something to look forward to. Perfect. Yeah. So if that's all okay, then we're going to get on to this one. Distance time graph. Perfect. So this is again something that some students struggle with. It's a 3-mark question. So the distance time graph shows information about part of a car journey. Use the graph to estimate the speed at 5 seconds. So to work out speed from a distance time graph, again, hopefully you know this from your science lessons too, you're just going to work out the gradient. Okay? Exactly, and you said tangent, perfect. Because if I look at t equals 5 seconds here, it's not a straight line. So instead I'm going to make it a straight line, which might be a bit tricky for me, but let's see if I can do it. Actually, no, it won't. What am I talking about? I'm lying to you. So what I'm going to do is, this is how I have to use my ruler, by the way. Might need to be a bit steeper. By the way, they do give you a range of values, so don't worry too much about being like absolutely perfect. But would you guys say that's a decent tangent? I'd say it's decent. Yeah. And yeah, so you do get kind of a bit of leniency with this, so don't worry too much about it. And all we're going to do is work out the gradient. So what we can do is, yeah, perfect, cool. How big is the allowance? So they tend to give you, okay. What I'll do is I'll open up the mark scheme and I'll check the range after we do the answer. How about that? And that'll help us. So what I'm going to do is I'm going to take this final point here and this point over here. And I'm just going to do the good old-fashioned big triangle. So that goes from 3 to 8. So that's 5. And this goes from 0 to... So what does this go up in? 5, 10, 15, 20... not 5. It goes in 64, 68. Okay, so it goes up in 4s. So this would be 64, 68... And it's halfway between. So I'm going to say it's 70. Yeah? So if you pick 68, that's fine. But it looks to me like it's just above 68. Right? Like almost halfway. Maybe you could say 69 instead if you want to be a bit picky. And then we're just going to do 70 over 5, which is 14 meters per second. So if I open up the mark scheme, if you give me 2 seconds, I'm just going to... Okay, so the range in this question was between 11 to 19 meters per second. So that's quite a big range, right? It's a pretty big range that they give you. So hopefully that's okay. Any kind of questions about that? I know that this can be kind of a bit of a scary one because obviously your tangent might change a bit. If it helps, you'll have quite a big, clear diagram. And obviously a ruler to help you out. Awesome, okay. And I think it's pretty quick for 3 marks, to be honest. Especially considering I had to use the mouse wheel to rotate it. Okay, let's go on to the next one. This is also a top... Yeah, I could already tell what this was. So this is also a topic students really dislike, which is similar solid shapes. So you guys are pretty good with scale factors, but when it comes to solid shapes, people start panicking. They start sweating. So we're going to unsweatify it. So we have the ratio of... You hate this topic? There you go. Hopefully I'll give you a pretty easy way of doing it. Okay, Lila's got the right idea. So let's say, I'm going to give you a bit of an easier example, right? Let's say if we have 2 squares, right? And this one has sides of 1 centimetre and this one has sides of 2 centimetre. I know it's a revolutionary, right? Revolutionary. To work out the scale factor, you just work out what you times 1 by to get to 2. Oh, perfect. Then that hopefully this will give you a bit of insight. I could write that as a scale of kind of 1 to 2 if I wanted to, right? But in this case, what they're trying to do here is they're saying that the surface area is 3 to 4. So I'm going to write that. So A to B, surface area, I'm just going to put SA because I'm lazy, is 3 to 4. Now, with surface area, the units are meters squared, right? If I square root it, I will get the scale factor for length. So square root both of these. That gives me the ratio, so square root 4 is 2. Because length is just meters, right? So if I want to get to the volume scale factor, all I need to do is cube this, because volume has units of meters cubed. So this is just going to be root 3 cubed to 8. Is that okay? So, actually this would be square root 27, wouldn't it? Yes. That's the same as square root 27 to 8, by the way. So Mara, so far is that okay? So surface area, since it has units of squared, if I square root it, I get units of meters, which gives me the length. Then I cube it to get up to volume, which is meters cubed. Yeah? Perfect. Now, it tells me that the volume of shape B is 10. So it's telling me that this is 10. Yeah? I need to work out the volume of shape A. In fact, I'm going to move this down slightly so we have a bit more space. Now, the way I always do scale factor now, because I think it's easier for people to understand, is I ask myself, what do I times 8 by to get 10? Right? I would times it by 10 over 8. Right? All I do to work that out is I do 10 divided by 8, which is 10 over 8. So what do I do to the left side? I do the exact same thing. Times by 10 over 8. I will say mark schemes are pretty bad at explaining this because they're not really meant to explain. But the volume of A is just going to be 10. Sorry, not 10. Root 27 times 10 over 8. And then whatever that number is would be our scale factor. Our actual volume. So square root 27 outside the bracket times 10 over 8. God, that's hideous. Does it say how many? 3 significant figures. Okay, so 6.50 to 3 significant figures. Okay. Does that make a bit more sense to everyone? Especially you, Mar, if you found this a bit tricky. It says aiming for a grade 9 plus. Yeah, absolutely. I'll zoom out slightly too, so you can see the whole thing. There we are. So don't forget, Evie, not all of these are grade 9 questions, but you're going to see a lot more grade 9 questions, if that makes sense. This scale factor topic is grade 8 or 9, actually, in this case. Maybe 8. Yeah, yeah, it's 8 or 9, actually. Yeah, I'm pretty sure it is. And you might say it's quite simple, and that's good, right? But you would be surprised. This type of question is what most students just skip or get wrong. Like, there's huge problems with this type of question, which is probably why they put it in this year as well. Right. Where did the 2 come from in 2 to 10? Oh, that's a question mark. That's a question mark, not a 2. My bad. My handwriting is atrocious. Surds look much worse. Yeah, I agree with you. But it's just what's graded. Yeah. Yeah, I apologise for that. It's meant to be a question mark. Okay. Probability. Another topic that a lot of students suck at. No offence to you guys. But you guys do kind of suck at it. Not you specifically, but in general. So when a biased coin is thrown 4 times, the probability of getting heads is 16/81. Work out the probability of getting 4 tails when the coin is thrown 4 times. It's a 2-mark question. So you're going to remember, it's going to be a pretty tricky topic. What we will do here is, first of all, I'm going to write an equation which gives me this. So the probability of getting heads 4 times, head 4 times, would be the probability of getting heads to the power of 4. Flip it, and then flip it, then... You gave me a stroke, Lila. Jesus Christ. Flip it, then it... God, almost... Okay, yeah. Either way, does it make sense you just do the probability of heads times itself 4 times? So probability of heads, then heads, then heads, then heads. Okay, and we know that equals 16/81. I don't mean flip. Yeah. 81 over 16. I don't think that would work the way you think it does. So the way I would do it is I would work out the probability of getting heads, right? Which would just be... I don't know if this actually has a name, but you're taking the 4th root of 16/81. Because if you're saying flip it, then that wouldn't... Oh, are you just saying it would be 81 minus 16? Not quite. Not quite. Yeah, you're going to work out the probability of tails and multiply by 4. So, Lila, you're correct there. We need to work out the probability of tails. So, okay, perfect, Ma. No, not quite. So yeah, we are working out the probability of tails, right? And to do that, Ice Cream said it was 2/3, and I believe him because he's correct. So if you think about a coin, there are only 2 options, right? Heads or tails. We're going to ignore like landing on its side for now, okay? So that means the probability of getting tails is going to be 1 minus 2/3, because if you remember, all probabilities have to add up to 1. Okay? So it's 1/3. Why is it about 4? Okay, this is a really good question. Yeah. So, when you're throwing a coin 4 times, and you're getting heads 4 times, what that means is you're getting... God, sorry, I'm having a bit of a hard time here. I'm going to copy this, paste it. Cool. So what it means is you're getting the probability of heads, and you're getting another heads, and you're getting another heads, and you're getting another heads, right? Now, whenever I say the word "and" in probability, it means to times. Okay? That's why we times it by itself 4 times. Okay? If you multiply it by 4, you're just working out an estimate for how many times you're going to get 4. So if I just did the probability of heads times 4, that gives me an estimate for how many 4s I should get. Yeah. Sorry for having a bit of a stroke there, Jesus Christ. Okay. So the probability of getting a tails is 1/3. So the probability of getting 4 tails would be 1/3 and another tail, so times a third, and another tail, so times another third, and another tail, so times another third, which is 1/81. So yeah, probability sucks, and you don't really get that many marks for it. But have a look at that, see if it's okay. Oh, man. Is everyone okay with that? I know it's a bit tricky, because probability is tricky. Easy? Good. Yeah, if you understand probability, then it's not too bad. But understanding probability is a bit of an obstacle, to be honest. Cool, yeah. Wonderful. Oh, this looks fun. Actually, we did a question very similar to this last week, I think. So A, B, C, D are points on the circumference of a circle. A, E, C, and D, B. Yeah, cool. Prove that A, B, E, so this triangle here. Yeah, I'm sorry for my drawing. And D, C, E are similar. You must give reasons. Okay. We already did it. I feel like we did a very similar question, but I don't think it's the same. No, it is. You're right. We did this question, didn't we? Yeah. So you just use the fact that angles in the same segment are the same. So that means C, D, E. So this angle here and this angle here are the same, because angles in the same segment, and then you do the same thing for these two angles. I think it is ice cream. I'm not gonna lie. Interesting. And then you can actually say that these opposite angles are equal too. Yeah. So because they have all of the angles, oh, it's saying why they're similar, which means that it doesn't mean they're congruent. So what it means, they've been stretched by a scale factor. So all three angles are the same. Which, if you remember, there is no congruency for AAA for three angles. So because all three angles are the same, the triangles are similar. Don't forget the word similar means if you stretch it by a scale factor. So these actual sides aren't the same. Or they're not necessarily the same. That's why the question's similar, but it's not identical. Yeah, so as Evie just said, the only ones for congruency, which means they are identical, is side angle side, SAS, angle side angle, ASA, RHS, so right angle, hypotenuse, and another side, and SSS, the three sides being the same. So this is for actually them being similar. So that was quite lucky. Does that make sense? Can everyone see why all three angles are the same? I can go through it one by one, if that helps. I recognise that this looks really complicated. Goof? Good, oh. As in the one with three, yeah, sure. So if I go through the last one, I'm going to get rid of everything except... You don't get segment theorem at all. Okay, let's go through all of them. The first one, which I think is actually the easiest, is these two angles are actually the same. And the reason for that is, if you have a look, it's an X shape. I don't know why I'm doing that. If you make I'm doing the Wakanda forever thing. Alright, if you make an X shape, right, the angles on the top and bottom are always the same, and the angles either side are also the same. And that's called vertically opposite angles. Okay? So yeah, this just means vertically opposite angles, okay? And basically, if you ever make an X shape, the top two angles and the side two angles are the same as each other. Does that make a bit more sense, Mar? Can you see it's just an X? Perhaps I should highlight it. Yeah. Yeah, I know. So, Mar, does that make a bit more sense? How many marks is this question? It is a 3-mark question. So yeah, the first thing is that these two angles are identical. Now the other angle I'm doing, so I'll do it in a different colour just to make it a bit more clear, so let's use like a red or something, is that these two angles are also the same. And the reason for that is if I follow these lines that make up the angle, right? So follow these lines, follow them, follow them, follow them, follow them, follow them. If you have a look, can you see they're made up of the same 2 points on the circumference? Any two angles that are made up from the same 2 points on the circumference have to be the same. And that's called alternate segment theorem. Angles in the same segment are the same. Okay? And the reason for that is if you have a look, they share this segment here. Lila, does that make a bit more sense? The segment's here. This curved shape. So technically, when it says angles in the same segment, it's a bit complicated. They each make their own segment, right? So if I rub out one of these, can you see that that is a segment? It looks like a weird one, but it is a segment here. Okay, perfect. With practice, and then it's also the same on the other side. If you want the paper, I'll put it in the chat now. Give me 2 seconds. That's the paper in the chat, by the way, just in case you want to do it. So in an X shape, it's always vertically opposite angles, even if they're on... Yes, always. Yeah. And then lastly, you're very welcome. Thank you for joining in. For the last one, we have these two angles are the same. For the same reason, if you follow the lines along... Oh, God. You know what? I'm just going to accept that I can't draw and then... Can you see that they share this kind of segment over here? So they must also be equal to each other. Okay. So hopefully that makes a bit more sense. But yeah, all three angles are the same, and therefore it is a similar triangle. They are both similar triangles. Whew. Pretty good, right? Cool. We'll do one more question, and then we'll accept the questions from the people in chat. That might be a good way to finish it off. So, oh God. Great, I picked a proof question. My bad. All right. The nth term of a sequence is 2n squared minus 1. The nth term of a different sequence is 40 minus n squared. Show that there's only one number that is in both of these sequences. Okay. So it does say... Oh, okay, this is fine actually. I thought I was going to have to do like a full-on algebraic proof, but you don't. Yeah, you just list them. So in this case, it's completely fine. The reason why I hesitated is I thought we might have to do like an algebraic proof. So 2n squared minus 1, you can just do... It's a very nice question, yeah. You can just use a calculator, you know, and just sub in numbers. Again, don't forget the terms always start from 1, not 0. And then keep going like this. I mean, that was pretty obvious. So 1, and then we can keep going, right? And so on. So let's start doing it in our heads now, because this is getting a bit tedious. So the next one was 7. The next one would be 2 times 9, so 18, that would be 17. Next one, 5 squared, 25, double it, 50, 49, and then so on. Okay, so I'm going to stop there for this one, because if I look at this sequence, I can see it's actually getting smaller from 40. So now I've gone above 40, I know that they're not going to match anymore, right? Because this will keep getting bigger, whereas this one will keep getting smaller. That's why I stopped. So 40 minus 1 squared is obviously 39. 40 minus 2 squared is 36. 40 minus 3 squared is 31. 40 minus 4 squared is 24. Then it would be 15. And so that's 40 minus 25. 40 minus 36 would be 4. After that, it's going to go negative, so I know it's not going to cross over. So if I have a look, the number that's in both of these is... Wait, did I miss one? Oops. I made a mistake. There's another value before 49 that I missed out. What I did there was... Yeah, so I did 5 squared, so I didn't do the 4 squared. 16 minus 1, that would be 31. Yeah, I didn't do 4 squared. This was 3 squared times 2 minus 1. I missed out 4 squared times 2, which is 32 minus 1, then 5 squared times 2. Okay, that's my bad. But the one that's in both of them is 31. Okay. That's 3 marks. So you get a mark for listing this one, a mark, and then obviously a mark for getting the right answer. Pretty short. Pretty easy. So yeah. I got confused as well. I was like, And then I realised I only had 4 values in the top row, which means I must have missed one accidentally. Which is why you don't be arrogant like me and actually use a calculator. But yeah, that's completely my fault. I'm actually going to redraw this. So we have about just over 10 minutes left. So a few of you had questions. So you can either email them into me. My email is, I'll put it in the chat again. Or you can type them in the chat if you're able to. So I think Evie and Ma, you had one. So if you want to just send them over. I just googled Google, I can't believe it. But if anyone else has any questions, you can. Hang on. Do you want easy circle or jarring ratio? Yeah, question 22. Okay, I'll take the one that Mars sent first. And then ratio is still not bad. Okay, so what I'll do is I'll do Mars' question, then Evie, you can send both of your questions. Send both, it's fine, we'll probably have time. We'll overrun a bit if we have to. Rest is for the weak. Okay. So, I'm just gonna, there we are. Zoom in a little bit. Okay, this one looks pretty horrific. Thank you, Ma, I appreciate it. So I'm going to just put this on the side somewhere. Okay. So this is the question. How many marks is it? It is a 5-mark question. So I haven't actually read the question yet, so I'm just going to let everyone know where you can get it from. This is Edexcel. Mock set 5. So I think that's on the actual list of stuff that I gave, maybe? There's this hexagon shaded region question. I don't know where I saw it. I think I might know where you're talking about. Maybe I can get it for next week. So yeah, question 22. So we have A, B, C are 3 similar solids. The surface area of A is 24. Surface area of B is 54. The height of B to the height of C. Actually, okay, what I'm going to do here. A to B, in terms of surface area, I'm going to put as 24 to 54. The height of B to C, so that is length, by the way. So when you have a height, since it's one-dimensional, it's always going to be a length, and that is, maybe I should do something like this. This could be funky. B to C is 3 to 7. So can you see I'm making like a table type thing? The volume of A, so then we have volume. A is 72. This last piece of information, it's useless at the moment, but all they want us to do is work out the volume of C. Because remember, when you have density, you times density by volume and you get the mass. Okay, so we can ignore that for now. We need to work out the volume of C. Okay, so what I'm going to do here is, if we cube that, density is mass over volume, good. So if you want to get mass, then it's just density times volume, perfect. So to be honest, I don't think this is too bad. You said 4 to 9, so it's the same for that one. Okay, I'm just trying to see if there's any trick here. I don't think so. So if we have the ratio of B to C, what we can do is cube it to find out what the ratio of the volumes is. Okay? You want me to switch the SI in length? Okay, fine. I do agree it was a bit confusing, but... Okay. There is one thing I should say. This isn't the best way to lay out the information, actually, because we don't actually have the ratio of all three of them together. They're actually all separate ratios. This is just going to be a table for me, okay? So what I can do here is... work out the ratio of the surface areas for B to C. So B to C surface area is just squaring both of those. So it's just going to be 9 to 49. Right? Because all I've done is squared this ratio. Are you going to live stream next week? Yep. So yeah, I'll be live streaming over the Easter holidays as well. All the way up until the last exam. Yes. Cool. Now if I work out the length scale factor for this, I can use that to relate A, B and C. Okay. Thank you. So A to B length is the square root of 24, which doesn't have a square root. Square root of 54. Okay. Now the reason why I'm doing that is I need to relate A, B and C as one common ratio. Does that make sense? So I'm going to try and work out A to B to C for length as one common ratio. So at the moment I have A to B and I have B to C. So since they're common, what I'm going to do is... Hang on, can I? Yes. It's the ratio, yeah. So ratios can be the actual values, like I've done here, like when I wrote this as a ratio, but not necessarily. So for now, it's a ratio. So actually, I want to simplify this. So simplify surds. What could I simplify root 24 as? In fact, wait, why am I doing this? I've got a calculator. Wait, this was a calculator question, so anyway I can write root 24, 2 root 6, perfect. I'm being nice and lazy, as any real mathematician is. And root 54, aha, it's 3 root 6. Okay. So, if you notice, okay, I've laid this out horrifically, by the way. So for length, B to C is 3 to 7. And A to B is 2 root 6 to 3 root 6. So if I want to combine this into one big ratio, all I need to do is times this ratio by the square root of 6. Does that make sense? So 3 root 6 to 7 root 6. And now I have the ratio from A to B to C, which is 2 root 6 to 3 root 6 to 7 root 6, which, funnily enough, means I can actually cancel out all of the root 6's. So it's just 2 to 3 to 7, which is very satisfying. Okay? Because don't forget, I can divide them all by root 6. Because you can simplify ratios, right? So far is that okay? This is for the length. Okay. Okay. I apologise that this was written out horrifically. To work out the volume scale factors, or the ratio, all I'm going to do is cube all of those numbers. Okay? So 2 cubed will give me 8. 3 cubed gives me 27. 7 cubed is a very good question. It's 49 times 7, but I don't know what that is. 343. Cool. I feel like I should know that. But yeah. So that's the volume scale factor. Now we know that the volume of A is 72. Yeah, I did kind of go in a bit of a roundabout way. So the volume of A is 72. So to work out to get from here to here, I times by 9, right? So to get the volume of C, I also times by 9. 343 times 9 is 3087. So the mass of C is equal to density times volume. Density was 0.14. And that'll be my answer. So yeah, Evie, I agree with you. I've actually done this in not a very efficient way. I should have read the question like clearly. So 432.18. So here's what I would change about my method. But yeah, that should be the answer. If it isn't, I'm going to retire from teaching and live in the Himalayas. But that'd be my answer. What I would say is this stuff up here. You're very welcome. This stuff up here is kind of pointless. I shouldn't have done that. Yeah. This is the actual good stuff. I did try and explain it, which is why it is a bit of a longer method. Even here... Actually, no. I'm happy with it. I'm happy with the rest of it. It's okay. I like that question, though. I'm going to put a little bit of an asterisk. I might do a video where I actually go through it in a bit more of a clean way. And I spent... Bloody hell. Okay, that was a bit of a long time. Evie, do you want to send your questions? And then we'll end with that. I think I kind of get this topic now. I'm really glad. Good. With practice, it will come to you. I promise. Maths is all practice. And a little bit of a... You did send? Oh yeah, perfect. So I'm going to pick the one that I find... Okay. Do the ratio one first. Okay. I was going to say I'll do the easiest one. I hope you... Thank you. I'm so glad that I do this for you guys. I hope... All I see is surds. Alright. All I saw was surds. Okay. A is root 3 plus root C. B is 7a plus root 12 plus root d. If C to D is 1 to 4, what is the ratio of A to B? Yeah, thanks. Appreciate it. Ooh. So if I use this, if you remember, you can do this. C over D is equal to 1 over 4. Right? So with ratios, you can just change them straight into fractions like that when they're equal to each other. So all I need to do is rearrange for C and rearrange for D, and I should be fine. Ah, perfect. Good. Whew. I started sweating there for a second. So if I rearrange this top one for C, all I get is... So move the root 3 to the other side, I get root C equals A minus root 3. I don't think I need to actually square it. Yeah. What I'm actually going to do is I'm going to work out root C over root D, over D to make it easier. So yeah, I'm going to leave it like that for now. And for the second equation here, I'm just going to make that root D. I'm going to show you a bit of a pro gamer move right now. 12. What I can do is... Actually, is that going to be easier? Nah, it's not. Alright, I'm going to square it. Alright, so C is equal to A minus root 3 squared. And that means A is going to equal... I'm just squaring both sides, by the way. Squared. So if I do C over... Sorry, that's a D. I didn't even read my own writing properly. Okay, that's a D, so... D. Okay, so C over D is going to be A minus root 3 squared over... Oh, God. Okay, this is going to take it... Why do you find these questions? Alright. And then all I need to do is get A over B. So I need to rearrange this for A over B by itself. And that's it. Is there? I can carry on? I mean, if there's an easier way, I would appreciate knowing it. No, I'm joking. Okay. Is there... Now, see, now I'm thinking about what the easier way is. Okay, first of all, with root 12, I can write that as root 4, root 3, and that's 2 root 3. The reason why I'm looking at that is I see I have a root 3 in the numerator, so I might be able to get rid of it. Wait. Okay, I'm being a bit stupid. I don't need to expand the brackets. I can square root both sides to get rid of the squares. Substitution? And don't forget the root 12 changes to 2 root 3. Now what's the square root of a quarter? It is a half. So that makes my life ever so slightly easier. Substitution. Oh, as in you sub in... I did think about that. So do you sub it into like the equation, like sub in what C is into here? Is that what you mean? Because if so, I did think about that. And then using my big brain, I decided to do the hard way. If that is the case. Rearrange for C. Yeah. Crap. Alright. But then that would just give you A equals root 3. Oh, and then you sub in for root D. Is that easier? Is that really fast? Right. Anyways, I'm going to times the whole thing by both things. So I'm going to times it by 2. And I'm going to times it by B minus 7A minus blah, 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 blah. So that would give me on this side 2A minus root 3 equals B minus... Is this likely to come up? No. This won't come up. If this comes up, I'll be very upset. Ooh, this is getting nice now. This is getting nice. So these two things actually cancel out because if I add 2 root 3 to both sides, they magically disappear. And then what I'm going to do is I'm going to move the A's to this side over here. So I'm going to add 7A to both sides, which gives me 9A equals B. So to work out the ratio of A to B, what I'm going to do is basically work out what A over B is. So then A over B would just be 1 over 9. So A to B is 1 to 9. They won't be able to read my exam paper because it will be smudged if this goes... I mean... Yeah. This is the kind of question you show to your parents to show how much maths you know. Right? Like, it's just a bunch of letters and stuff. Good lord. Oh, my throat's killing me now. I'm correct. Well, yeah. I never thought I'd be tested this much in a bloody... when I'm a teacher. Won't even attempt it. To be honest, this wasn't as bad as I thought it would be. It's a very good question, so I'm actually going to put another asterisk next to that one. So you said it's a Sparks Maths question. Good lord, man. Anyways. Okay, the other one that Evie gave me. So I'm expecting this to be very upsetting. But it looks like an actual exam question. An AQA one. So... this should be human, at least. Much nicer. Okay. Here are a circle. I'm pretty sure it should say here is a circle, not R, but okay. Here is a circle and a sector of a circle. They each have radius R. Work out the sides of angle X because the circumference of the circle is equal to the perimeter of the sector. And R is the same. Okay, cool. Give your answer in terms of pi because I'm assuming this is a non-calculator paper. Cool. So, first of all, the equation for circumference is 2 pi R. The perimeter of a sector will be x over 360 because remember the kind of this curved edge is just going to be a fraction of the circumference times 2 pi r plus 2r because we have those two radii bits there. Pi d is better, but we only have r in this case, so we have to double it anyway But you're right, pi d is usually better. So we have 2 pi r equals x over 360 times 2 pi r plus 2r. The first thing I'm seeing is I can cancel out 2 from everything, and I can cancel out r from everything. So I'm left with pi equals x over 360 pi plus 1. Yep. Okay, give your answer in terms of pi. Then I'm just rearranging for x. Okay, I was trying to see if there's like a nicer way of doing it. Minus 1 from both sides, get pi minus 1 equals x over 360 pi. Times both sides by 360, you get 360 pi minus 1 equals pi x. Divide both sides by pi and we get something hideous. Wait, where did I get... Yeah, never mind. I was saying, where did I get x from? Is that the answer? I think so. Should be. They may have rearranged it slightly differently, to be fair. But that should be fine. Cool. The algebra is a bit funky in this one, but is everyone okay? Can everyone see why I can cancel out the 2's and the r's everywhere? Easy. Yes. Whew. Okay. So this question was actually an AQA past paper question, Ice Cream. This one here, I have no idea, but Lila seems to have spilled the beans and said Sparks Maths, which I haven't actually heard of. So, I don't know. This one I have no idea, but this one is an AQA Maths question. And keep in mind that all of the specs, so AQA, Edexcel, WJEC, they are all they're all the same. As in, they have to teach you the same things, they have to test you on the same things. Mr. Hegarty's. Oh, okay. Boring as hell. Yeah. So all of the exam boards are actually the same. They just so it's good to do like different exam boards and get used to the questions. Assuming you've already done all of your past papers. I do like the questions. It's very useful, and it helps me because I don't have to plan as much. No, I'm kidding. It is nice to be kept on my feet. Edexcel's so much better. Yeah, it's opinion, right? But I think we will keep it there for now. And we can maybe do paper 3 next week. So I have paper 3 ready. Paper 3 has, oh my god, it has like statistics stuff. So it might be quite useful. Yeah, that's true, Evie. Thank you so much. You're very welcome. Yeah. So this is quite interesting. This will be like a statistics type lesson, but the hard statistics, okay? You're very welcome. I hope you all have a really good week, and I'll see you next week for the half term. So yeah, make sure you get some rest over the half term, but, you know, take the weekend off and then head back to the books, I'd say. But you all deserve a fairly good rest. You're very welcome. And don't forget, these will be uploaded anyway to YouTube, so you don't have to look at this on time. See you guys later.